Thank you for the patience. So I'll try to keep it fairly short and introductory for the main reason that unlike we have these awesome sounds shareable between us just because most of us have some speakers already, we don't quite have haptic displays at our disposal just yet at the same rate. So instead, what I was thinking, as this is my first joining in the meeting, I'll just explain a little bit who I am and what I work with and leave maybe a few more minutes for questions so we can talk about potentially how this haptification could be used with sonification. Right. Okay, so as I was saying, I'm from the University of Sussex, and this is where I've done my physics research or physics undergraduate, and later on I decided I'm just more interested in science communication and especially how we can use touch to communicate science. So I decided to start a PhD. All right, so can you see, those of you who have the screen in front of you, can you see the image? Just a very iconic graphics I'm usually using. So to give a quick description, what people are seeing is two hands, and they are sort of copying a illustration of an atom. But what I would like to point out that the atom, or the illustration of the atom, is kind of hovering in midair, just above the hand. So this is kind of the iconic overview of what I'm trying to achieve in my PhD, and that is to merge three already interdisciplinary fields, and one of them is haptics, or the science of touch, and science communication, but also do it in a way that you don't have to use any variables or any kind of technology that kind of restricts you. It's all midair and natural interaction. All right, so just a little bit about myself. I'm coming from Hungary. I was born in Hungary, but I've been living abroad for many, many years, and especially the last 7 years I've been living in England, where I've done my physics, theoretical physics undergraduate and master's. But as I said previously, I got more interested in how we can actually communicate the science to people. So I decided to put more effort into science communication and novel ways of doing it. And it's probably clear by now, but I'm also blind, and I've lost my sight around 10 years ago. So I know what it was like to study science or just stargaze through a telescope visually, and I know the kind of challenges and the loss of just sort of hedonic experience when you cannot see things. All right, so let me talk a little bit about mid-air haptics. So one way that we might think about this is sonification, but inaudible, because the technology, especially that I'm using, is mainly deploying ultrasound to create tactile sensations in midair. And that was something that people discovered in Japan, or at least the team in Japan is credited for it back in 2008. And from that on, it picked up quite quickly, and the research team in the University of Bristol in England started to work out the more engineering details, the product development details, and commercialized the ultrasonic mid-air haptic technology in 2013 and built a company around it. And just to very briefly give you an idea, what you should imagine is an array of ultrasound speakers, a bit like those you're using in a car for the parking radar. They all emit 40 kilohertz ultrasound, but the phased array is modulating this sound just because we wouldn't be able to feel a very high frequency vibration on our skin. The tactile acuity of the human skin goes between kind of 0 and 500 hertz frequency. So we have to modulate the ultrasound. But not only that, we also have to focus all these sound waves into one focal point to give a high enough sound pressure that can cause an indentation on the skin. So we can get back to this with a few questions if you would like to know more about it. Okay, oh, sorry. Right, so why this is potentially good for science communication. So in one of my studies, we asked a group of science communicators to use the technology, try a few concepts that we programmed, like a cell nucleus, particle collision, a few other things, quantum phenomenon, and ask them, why do you think this is better than some of the other technologies you've been using before, things like sonification or 3D printing or virtual reality. And one of the key things that people picked up is that it's tactile, which makes sense, but also that it's dynamic, it's programmable. So unlike with a spring where you want to illustrate an oscillatory movement in touch, as soon as you touch it, it basically, you disturb the movement. Whereas with this technology, you can create tactile and dynamic sensations, and you wouldn't disturb this ultrasound field with your hands. So that was kind of the biggest thing for people. But also it's quite useful because it's invisible and it's kind of suspended in midair. So you don't have to have any gloves or anything. It's just there in front of you. So that's a quite big potential for combining with other modalities. For example, the visual in virtual reality or even sonification. Okay, so let me just talk to you very quickly about 3 of the projects I've been lately doing. So in one of them, we collaborated with Imperial College London and put on a multisensory exhibition of the dark matter. So it was very metaphorical. It wasn't necessarily just a data haptification, data sonification. It was using all the 5 senses to create a narrative around going from planet Earth to the center of our galaxy and the variations in the dark matter wind. So we used scent technology, haptics, sounds, partly sonified, partly audio narration, and visuals as well. So later I might ask Kate to share this file with you, or I can try to put it on Google, but there's a video for you to have a look. There's more details about the project. Okay, so as with the dark matter experience, that was more for the general public, exhibited multiple times in the London Science Museum. But we have done also another project in the US, in Los Angeles, with the Aquarium of the Pacific. And they especially asked the company who's funding the PhD and producing this technology to try to make their movie experiences about oceanography, renewable energy, more immersive and more accessible for sensory impaired people. So in this project, we mainly focused on what you can see on the screen. So let me just quickly wrap up on this. So Aquarium of the Pacific, yeah, we basically, the main target was to see whether we should one-to-one map what you can see on the screens. For example, when you see a fish swimming on the screen or a windmill, would you actually want to feel the same sensation on your palm with this midair haptic technology? Or is it better to, again, be a bit more metaphorical and, and the narrative talks about strong winds, then you actually feel strong wind. You go more like a haptic narration. Yeah, and some of the feedback was really good, and it was a commercial project, even though it was kind of science communication. So as far as I know, there is some second projects coming up on that. Okay, some of the other one, which is more closely related to what I'm doing is, so I'm going to hopefully present my demo in Eurohaptics, which is the European Conference for Haptics in September. And what we have been doing is actually similar to what we heard today about the first project. I think it was Sophie, if I remember correctly the name, about shapes. So the whole idea was how we can haptify shapes, just circles, triangles, squares, and what's the best method of rendering that you perceive it with the highest accuracy. And whilst we did that, we did the actual user study. We did achieve like a 30% increase in just by different methods of rendering shapes, which fortunately I cannot show you now through the sense of touch. But again, there is a video which illustrates for you to have a look at later. But not only that, we kind of worked out a way to render shapes in a more perceivable way. We also realized that whilst we created a video which has closed captions, and it has the sort of visual animations, and it has the narration to explain what's happening, what people can see, we also realized that because it's a quite simple concept that we are trying to explain, just geometric shapes, and we wouldn't necessarily be able to overlay an audio description on top of the narration, or it wouldn't work very easily. But what we could do is include a closed haptioning. So basically what you would see on the screen is what you could feel as well. It's a bit like the opposite of what we've done in the Aquarium of the Pacific. Okay. Yes, and I think I'll just quickly conclude there because we are a bit over time anyway. But yeah, so all I'm trying to say is that I really believe that touch has potential in science communication, that will be more of the formal or informal learning environments. And from the presentations, what I heard today, I can imagine combining sound and touch would be quite awesome in lots of different scenarios. But with that, I would like to thank you for now. And of course, feel free to ask me now or later as well. Thank you.